And Mr. Armke back with you for CTS-120. Let's jump into our new chapter today. Chapter 6. We're going to be talking about supporting input and output devices, usually abbreviated as I/O. So we're going to talk about our general support approach. We're going to look at configuring and installing several different devices, barcode readers, pay devices, webcams, touchscreens, etc. We're going to look at how to set up adapter cards. We're also going to look at supporting the video subsystem, including a monitor and video card, as well as supporting multiple monitor systems. We're going to troubleshoot some common problems. And lastly, we're going to talk about customizing a computer system to meet some customer needs. So this is a perfect tie-in to where we're going to be getting into our term project. So our basic support principles are the same for peripheral devices as they are for internal core devices. It's just more of a likelihood that we're going to unplug them during the operation of our normal usage. So input and output devices can be internal or external. Device Manager, as you guys have played around with in lab, is our primary tool for managing hardware. Within Device Manager, we can turn a device on or off, update its drivers, roll back a driver if necessary. That's undoing a driver update when something's non-functional, or just removing a device completely. Now, every device is controlled by software. That's the driver. There is also sometimes application software necessary for certain devices we may deal with. The best guide for installation and support is going to be the manufacturer. And I'm sure some of you are kind of chuckling about that, but it's true. Hopefully, if anyone knows anything about it, it should be the people that made it. So we want to make sure that we are dealing with that in the smartest way possible. And that is to look at what they intended it to do originally. Some devices will need application software, as I said. Important thing to know is that devices do have limitations. No matter how fast of a computer you hook something up to, there is an internal limit to how fast a device can work, and that's based on the port or slot it is designed to use. When we're working in Windows, we need to use an administrator account to be able to install devices effectively, because in order to prevent potential rogue intrusions, device installations are going to be fairly limited under standard accounts. Sometimes problems are solved by updating drivers or firmware, or they can be caused in that way. A poorly designed driver update, especially if it's not compatible with the operating system you intend to use, can create a lot of problems. We also want to make sure that we're paying attention to our traditional order of operations, and it's that we only want to install one device at a time. We want to involve what's called singular operations as opposed to Big Bang installation. Big Bang installation is a little bit closer to Big Bang programming. It's a term that I first learned as an undergrad, and it's when you do everything at once, it's really hard to determine where a problem came from. So in that case, we will usually want to do it one at a time. So if we run into an issue, we can then streamline the process of solving that problem. So here are just some standard peripheral devices and their speeds. So you'll see some stuff you recognize, I'm sure: Thunderbolt 2 and 3, USB 3.0, eSATA, Wi-Fi. Here's some older ones: Lightning, USB 2.0, USB 1, and some older versions of Wi-Fi as well, bands A, B, and G. Bluetooth is there, NFC. All of these have different applications, which is why, the fact that Bluetooth is nowhere near as fast as most of our Wi-Fi or USB connections doesn't really matter. What it works well for is transitioning information wirelessly over short distances in a relatively secure fashion. NFC, same thing, except it doesn't have to be super fast. It just needs to be used for stuff over an incredibly short range. That's usually for things that are physically being authenticated, like RFID tags. Now let's look at some common peripheral connectors and ports. USB, the big daddy of them all. This is a universal serial bus. The technology allows for up to 127 USB devices to be daisy-chained together. I don't tend to recommend this, but that is the theoretical limit of the standard. USB, as you might imagine from the universal serial bus, uses serial transmissions, and that means that devices are then able to be reinitialized much more easily, so they're now hot swappable, meaning that we can plug and unplug them without powering down. A USB cable traditionally has 4 wires, 2 for power and 2 for data transmission. Here we can see the logos for, and I don't know why they have them in fastest to slowest, USB 3.0, USB 3.1 is the one on the far left, actually that's the 10 gigabit, 3.0, and then 2.0 and 1.0. So 3, 2, and 1 from left to right. Video connectors and ports, there's a ton of different ones. They all have different functionality. They'll support, digital transmission versus analog transmission in some cases. Some will carry audio as well. So that would be things like VGA. VGA is a 9-pin serial video connection. Only carries video, not audio. DVI can carry both video and audio. I'm sorry, DVI only carries video. HDMI is a version based on the same standard that carries audio, but DVI can carry digital or analog transmission, depending on the version of the port. And then DisplayPort, we'll traditionally see those on newer video cards as well as Apple devices. So here we can see two versions of the same type of port. The left one is a DVI-D, which is a digital-only DVI connector. And then we have an interchange, which is on the right, which allows analog support as well as digital. So you'll notice they both have the same 3 rows of 8 pins, but on the right-hand side, we notice that there is a different connector on the right. There's 4 pins for the analog transmission, as well as the ground connectors there in that little cross shape. Here we have a DisplayPort to mini DisplayPort cable, and its closely related interface, the HDMI to mini HDMI interface. If you take a look at the physical plug itself, you'll see that it's roughly the same number of pins on each one. In certain cases, some of these will double up. For the most part, it should still be a 19-pin connector. It's just they're all on one edge instead of on 2. So here we can see in UEFI or BIOS, this case it's BIOS, we can actually go in and turn off certain onboard devices. This will vary based on who has made your motherboard. Just make sure if you are planning on installing a new device that you have a way of going in and disabling the onboard if you need to. A lot of the time the conflicts won't be problematic to a great degree, but it can be. So we want to make sure that we're dealing with those in an appropriate fashion. Some additional ports we may see: Thunderbolt, it's a multi-purpose connector for displays, storage devices, as well as for charging portables. So it is a very strong multifunction. eSATA, external SATA, it's used for connecting external storage devices. Lightning is Apple specific. Coaxial cable connectors, BNC, RG6, and RG50. RS-232, which was a serial type connection that we would use for connecting to things like a Cisco router or switch for configuration purposes. Usually the console line has been replaced by USB, so you'll see a lot of USB to RJ45s now to perform that connection. If not, you'll see an RS-232 RJ45 to serial connected to a serial to USB adapter. Simple input devices such as the keyboard and mouse can be controlled by the firmware or will have embedded drivers built into the OS. To install any peripheral device, the general procedures are this. Of course, read the manual first. Make sure your drivers are compatible. Make sure the motherboard port you need is enabled, plug it in, and install any application software needed to use the device. Now, any expansions on these directions will usually be found in the manufacturer's listings, whatever that comes with. So if that comes with a booklet or refers you to a website, things like that, this is going to be the general form that it follows. Now, in certain cases, you may have to install the drivers before plugging in the device or plug in the device before installing the drivers. That's why step 4 has an OR in it. If you plug in a mouse or keyboard, again, generic input device, Windows should automatically recognize it. Older PS2 ports are not hot pluggable, so make sure these are plugged in before Windows gets started. Be careful because there are certain types of malware that are actually dependent on devices identifying themselves as keyboards and mice. These devices don't have to undergo the same digital signing as a standard USB keyboard or mouse. Because you don't want the firmware to have to process anything before it starts responding. You want it to be able to instantly be able to access, spamming the F2 key to get into firmware or what have you. So if you ask Mr. Vandergriff about the pineapple and about the rubber ducky, those are two examples of USB devices that can be very, very dangerous to a system due to the vulnerability of not having to have quote-unquote signed drivers for these input devices. For any keyboards that come with special features, if there's a programmable macro or things like that, there will be special drivers that came with the keyboard or downloaded from the website. Again, we're going to use Device Manager to handle all of these peripherals. So here we can see an actual installed program that goes to a particular USB device. This is the Mouse and Keyboard Center from Microsoft. So there are certain ones that we may see that are listed as installed programs. If we're dealing with a laptop, we're going to go through the same steps we would for replacing anything in a laptop. We're going to remove the power, remove the battery pack, and we're going to read the service manual to see where the removal process takes us. So service manual, of course, being a much better usage of our time to examine the teardown process than dealing with the user manual. So in this case, we're going to assume that there's an access panel on the bottom of the laptop that we'll need to use in order to expose the ribbon cable. A lot of the time, you'll only have to remove the bezel on the top, and then you'll see where those cables lead. Again, read the manual before you get started. It makes your life so much easier. If you're dealing with a ribbon cable, traditionally it's going to be connected to what's called a ZIF connector, zero insertion force. We talked about these a little bit with CPUs. The ZIF connector for a keyboard is a little bit different. It's still the same idea. We're applying force evenly across the socket so we don't damage any of the pins or connectors. In this case, there is no real connector other than pressing the cable by means of the leverage of this little slot into its connector points. It's going to be little contact spots. So there's going to be a ribbon. It's going to have metal little traces on it, and those traces are going to rub up against contact points inside the socket. These can be very fragile, so you're going to want to make sure that you use tweezers and that you gently are able to lift the connector effectively and not damage it. Here we can kind of see what I'm talking about. It doesn't give the greatest explanation of how that's set up, but as you can see, they're using a thin Phillips head screwdriver to kind of lift the connector out of the socket. Barcode readers, these are peripheral devices that are traditionally used to scan, you guessed it, barcodes. It can be used on something at a point of sale. It can be used as a part of an inventory system. I know that I use barcode readers in order to inventory my books, especially my comics, to make sure that I've got all my issues filed correctly. If I have a particular device that I'm keeping track of, I like to, when I bought my new iPad, I went ahead and took a scan of the MAC address and all the stuff from the box, so that way I had it for warranty purposes. Barcode readers are very, very useful. Strangely enough, they only read the white spaces in between the black lines. So the black lines are actually a framing device, not the actual data itself. If you have a keyboard port to attach your reader, it usually is going to be a splitter system, especially if it's not USB, if it's PS2, and data will be read by the barcode reader as something like a normal Unicode character that would be used by the keyboard. So it'll bring stuff in and translate it that way. Pay devices such as your magnetic stripe or chip reader, this will send information through serial, USB, keyboard wedge, 3.5mm headphone jack. Strangely enough, a lot of people don't realize how much information can be sent over a headphone cable. Headphone cable traditionally has either 2, 3, or 4 wire segments. If you take a look at a headphone jack and you look at the number of little rings that divide the surface of the jack, you'll be able to tell how many channels it can send. If it's only 2, that's left and right stereo. If it's got 3, then there's probably a channel that can use like either a microphone or a button-based play or pause connection aspect. Tap pay devices can connect wirelessly as well. You need to be careful about that because a lot of the time that's how you run into what's called a skimmer. This is what you'll see installed in the front of an ATM or a gas pump pay slot for a credit card. This is where people will try and skim your pay information off of the surface of a credit card reader in order to use it for nefarious purposes. Signature pads, these will use touch-sensitive screens in order to capture a handwritten signature. The LCD panel will display electronic ink to register where it has taken contact. These traditionally are going to use serial or USB connections and often have to have special software installed on the computer to process that signature. Biometric devices, these are going to take inputs of biological data about a person to identify the person's fingerprint, handprint, face, voice, eye, or signature. Biometric, if we break it down, means it comes from biology, so the study of life, and then metric is just a measurement tool we use. So measurement of a person's life or their anatomy in some way. So they're taking something physical about an individual and using it as an authentication tool. Fingerprint readers could be just like you see on TV. You know, they've got a little like finger strip that you drag your finger across and it reads it. You can put your hand across a glass panel that sends that little red laser vertically, or green depending. You know, we don't think of them as being quite so sci-fi anymore, but it's the same principle. We're going to identify specific ridges and whorls on the fingertip or on the palm to be able to identify whether or not a person is who they say they are. And these metrics have to be taken by an authorized person and then stored in a secure database. So here we can see just a basic fingerprint reader, just a little glass plate or plexi plate going over the reader itself. On figure A, we can see that it looks kind of like a mouse. It's a little dongle that stays off to the side. Or in figure B on the right, we can see that it's embedded as part of the keyboard. Then, of course, now we have webcams that can use facial recognition. We have microphones that can use voice recognition. And then some of them are working together in order to combine different aspects of biometrics in order to figure out someone's identity. Webcams are installed on most laptops now. They're embedded as part of the screen. They can be installed separately using USB or most other ports. They'll come with built-in microphones, so that's what I'm using to record this lecture. As I talk to you right now, I've got my trusty Logitech. I'm going ahead and using that to narrate this. And if I had the option to, I could turn on video as well. But I don't want you guys to have to look at my goofy mug while you're trying to do some serious learning. Now, when you're installing a webcam, traditionally it's going to come with either like a little USB for the drivers, or it'll be plug and play. Very rarely does anybody include optical discs anymore. It's very passé, mostly because a lot of systems don't have optical discs, or if they do, they're external and they're a pain to plug in. A lot of the time what I'll do is I'll go directly to the website of the device that I'm looking for. Like Logitech uses what's called G-Hub. G-Hub allows you to manage all of your Logitech devices simultaneously. So let's say you have a Logitech microphone, like a separate standard cardioid stereo microphone, and then you've got your webcam, then you've got your keyboard, your mouse, and you want to unify all of those under one banner so you can check on their status and keep their drivers updated. Programs like G-Hub allow you to do that. Graphics tablet, also called a digitizer, is used to hand draw. It converts the input from hand drawing to on the screen. Very early ones, it was really tough because the digitizer would take in the input from the tablet. It would take a second to process and then put it up on screen. So if you guys are comic fans at all, in the early 90s, the first days of Image Comics, that was where digital coloring and digital inking really became prominent. So it's kind of crazy to watch that whole process evolve, and now we have iPads and displays from companies like Wacom that use like the Cintiq technology to where you're drawing on a giant pad, if you will. So these digitizing tablets tend to be little rectangular devices that you get that connect by a USB port. Some of them are going to use Bluetooth, and they allow you to use a pencil, specialized pencil called a stylus, that can register the same way as a mouse would. You know, if you've ever drawn anything in MS Paint or anything else, you know you can draw by dragging and dropping with a mouse, but the drag and click method isn't very efficient at, conveying pressure or some of the other nuances of drawing. So anybody who uses desktop publishing, if you've ever gotten a chance to play with a graphic tablet, you'd be amazed at how much it speeds up certain aspects of drawing. If you go through and you do your rough pencils, then you do your blue lines, and then you go ahead and reinforce your inking, the transparency is amazing. Everything's so fast. There's lots of custom brushes. The problem is that it makes people kind of lazy. So you have to, a graphics tablet is just a tool. Be careful not to let it substitute for actual practice. Again, technically speaking, it installs the same way as other USB devices, but if you want to use certain functions, you'll need to have certain types of application software, or you'll need to have particular drivers to make that work. A touch screen, very similar to what you'll see on your tablet or your mobile phone. It's an input device that uses a monitor or LCD panel as the backdrop for input. So if you have a touchscreen monitor, like a full-size monitor, most likely that is built in, but it can be installed as an add-on in certain cases. There are these plastic frames with these very thin laminate pages. They're not terribly sensitive, unfortunately, they're not very precise if the sensitivity is terribly high, and they'll overlay your screen. Generally, if you want to use a touchscreen, you need to get it as part of the original build of your machine. There is management software that will often be downloadable that will allow you to calibrate the device. They'll usually have you touch the center of the screen, then the four corners, and then carry out some basic input tasks to try and tell how do you perceive a double tap, how do you perceive a click and drag, that sort of thing. Virtual reality headsets, things like the HTC Vive or the Oculus Rift, even something as simple as the Samsung Gear VR. Samsung, when the Note 5, before it started catching fire, and the Galaxy S7 came out, they started giving away these headsets for pre-orders, and it was like a $100 headset. It's pretty cool. But it used the proximity of the lens, these magnification lenses, and the screen in order to create a stereoscopic experience that resolved to the equivalent of like a 70-inch screen. It was a very cool idea. You had a lens display, speakers, microphone, and you had head tracking sensors. So you used the same accelerometers from the phone that you would use to detect motion, but instead of having it in your hands, it was tracked to your head. There are some extreme gaming implications for this. There's military training that uses it. If you've ever played a game like Call of Duty or Counter-Strike Global Offensive in VR, you'll know that the effect is really staggering. It can give some people motion sickness because you don't feel like you're moving, but clearly when you're using your controls and stuff, you're getting the visual input. VR headsets can be programmed independently of the computer or be connected directly to the computer for recording or modifying the experience. Some VR headsets, as I said, include a dock for a smartphone. Make sure that if you are going to take advantage of this, that it's a dock that is built for your device. Google Cardboard's cool because you get to experience it on the cheap, but if you have the opportunity to check out some of the more high-end ones, the level of detail and the level of comfort is pretty staggering, because again, you're making your face very top heavy. You're putting a phone and all of the plastic periphery right there on the bridge of your nose, so you want to make sure that the headset itself is fairly comfortable. Here we have Andy Serkis's Gollum in Lord of the Rings, and the reason I include this graphic is because you can see there's a number of little white tracking dots all over his suit that he's wearing. And he's wearing blue because that is tonally the most different from human skin. There's also a lot of little dots that are kind of hard to resolve in the image that are on his face. If you get the chance to look up Andy Serkis mocap on YouTube, after you get done with this video, it is amazing watching that process. I have a friend that works in the mocap department at Epic Games up in Raleigh, and the stuff that he has shown me that he's been able to do is really, really impressive. So it's just a matter of finding ways to track movement, and that's what those little white dots do. We map to a skeleton in a 3D animation system to say, okay, this is the side of Andy's bicep. This is the front of the bicep. This is where his wrist pivots. This is the back of his hand. This is the left or right side of his head, blah, blah, blah. So then we have the gross movement, so we're able to map that. And we can attach a musculature and do a lot of animation. And then the facial animation is really intense because we're able to put a lot of these clustering dots together to figure out how they move relative to one another to register expression and things like that. This is probably one of my favorite technologies to talk about, even though it's just the one slide. So on the simpler side, stuff that you're likely to involve yourself with would be working with game consoles like the Nintendo Wii, or the PlayStation has the PlayStation Move, and then the Xbox has the Kinect series. So there's a couple of different game systems that rely pretty heavily on use of your body as part of the gaming experience. If you never got to try out Xbox Kinect for 360 and play the Star Wars version where you could be the Rancor and destroy villages, I highly recommend checking out videos of that because it looks hilarious, but when you're doing it yourself, it is incredibly fun. Now, because these devices are very unique, it's important to understand how we should connect them. We need to check our documentation to make sure, do we install the drivers first? Do we install the device first? Do we install the device, install a driver, reboot, and then install a second set of drivers? There's a couple of steps involved. KVMs. KVM stands for Keyboard, Video, and Mouse. This allows you to use a mouse, keyboard, and monitor it's in the singular for multiple computers. This is great for testing labs, server rooms. I personally have a media server where I use a KVM as well. So I have the media server just kind of sitting in the side of my desk. It's not a very powerful computer, but it does a lot of data storage and stuff. And I allow it to use one of my monitors for my standard desk display. So I just press the button on the KVM and it switches over, so I can use the same keyboard and mouse, use one of my monitors, be able to change what settings I need, and go back. This is helpful because with that particular server, I only need to change things maybe every other day. You know, go in, make sure that security updates are getting processed correctly, just a little bit of quick monitoring. Honestly, I could probably set up remote access through like my tablet or set it up to come up on a team viewer window or something similar, but I like having the physical interface. So the KVM really does work well for me. IO Gear makes some really awesome ones. You know, they've got this little 2-port one that I've got that I really like. It wasn't very expensive. It was probably, you know, 40 or 50 bucks. And that was at the time I bought it, so I have to imagine it's come down a little bit since then. The great thing about them is that they don't require device drivers. They are literally just pass-throughs. It's almost like an extension cable. So they allow you to kind of shift between one and the other. You can use a hotkey on your keyboard, so certain hotkeys will trigger transitions. I do not use that. I use the actual physical button. Sometimes there are also remotes. I've seen some that have like little adhesive pads on them that you can put on the top of your keyboard and be able to press to switch between one and the other. Sometimes you'll double tap something like the F9 key or something like that. You know, it just kind of depends on what model you get. Adapter cards and peripherals. Didn't change the section slide for this one. Don't know why. So when we're preparing to install an adapter card, we need to do a couple of things. Let's make sure that the card is going to fit. Some of you in lab talked about how you have a sound card in your toolkit, but it doesn't fit anything. Well, it's because it's left over from a previous lab setting where we actually had the older PCI interface that card would use. Let's go ahead and verify that we have the correct device drivers. Remember, 32-bit drivers, 32-bit system, 64-bit, 64-bit system. Back up your important data. Make sure that nothing is left out. And then know your starting point. We talk about this a lot. Make sure that the system is working normally before you add something to it. If you go adding things and it was already broken to begin with, you're never going to know whether or not it was what you did or what was already there. So we want to establish that early. Our general directions to install an adapter card are as follows. As always, read the documentation. Read it, read it, read it, read the manual. Please read the manual. If you're replacing an onboard port, as we showed a couple of screens back, make sure you disable the port if you can. It'll help to eliminate some of the conflicts that can sometimes cause problems with attaching a new card. Follow your standard ESD protocols, so make sure you're wearing your strap, make sure you're grounded, make sure you power everything down, discharge it, and be aware of the contact between yourself and components as well as components to one another. Locate your slot, prepare for installation, clear cables out of the way, make sure that the cover on the back of the I/O shield has been removed, and insert the card into the slot. Again, gently. We don't want to force anything. If there's a lock tab or security tab, we want to make sure that's clear. Anchor the card to the top of the slot with screws, connect any power cords or data cables, replace the case cover, plug in any essential peripherals, and then go ahead and boot up. Windows should detect that there's new hardware present and attempt to auto-install the drivers. Now, if you install the drivers beforehand, you may have to specify them from the install list, or it'll pick it up on its own, and then you can go back and correct it later. I have run into problems where the auto-installed drivers were wrong, so you have to go in, remove them, and install them from a new source. So again, if you're running into an issue, don't forget your troubleshooting steps. Don't neglect the obvious. Assume that everything that's going on already has been done wrongly, even if it was automatic. The operating system doesn't know. It's not an intelligent system. It's just it's self-operating, but not self-aware. If a CD came with the device, we want to make sure that we run the setup program because there may be some application software that's needed. Finish all of your steps. Please note, while doing these installation steps, you may have to reboot. So there may be some additional items that you have to worry about. So here's an opening menu for a CD that includes some video drivers. We can see that it's got video drivers, DirectX. We can install Fraps for screen capture and benchmarking, Adobe Reader for PDFs. A lot of bloat, unfortunately. So what I traditionally recommend is just install the video drivers. If you need any additional software beyond that, do a little research before you go dumping in whatever EVGA or MSI or whoever is willing to give you for free. It's usually, unfortunately, junk. Here's an audio card. This is a Sound Blaster X5 Titanium. Sound cards can play and record sound and save it to files. Color-coded speaker ports are often used for things like the speakers, subwoofer, any kind of additional controls. You may be able to connect external sound equipment such as a CD or DVD player. I remember one of my favorite things to do when I was a kid, well, I say kid, I was probably a teenager. My dad, when I was probably about 12 or 13, so think, you know, late 90s, he gave me his old hi-fi system, his old stereo system. So I took the 5-disc CD changer, the two cassette tape deck, and the receiver itself, and stacked them all up on top of the computer desk. And I had them kind of just off to the side. And I took this, you know, this was a miraculous thing to me. It was a 3.5 millimeter headphone jack to a 2-port red and white RCA audio. And I was able to take the audiobooks that I really loved from the library and dub them to my desktop, you know, be able to put them into WAV files. And then I took the WAV files, clipped the ends to make sure there was no hiss, things like that, be able to scrub them with some cheap audio programs and put them on CD. Because the problem I had was, and I'm almost embarrassed to say this, I fell asleep to the same books so many times that I actually caused the tape at the end of the cassette to snap. It would unspool. So I had to retape them, or I had to pay the repair fee at the library for them to do it. So it was easier to go ahead and get the digital copy and then be able to kind of put that on a burn disc and just put it in my CD player and loop it to my heart's content. It was also great for like really long books. Like the first time I read Dune, I wanted to have it read to me, so I can't remember who did the audio for it, but it was a British guy. And I think the audiobook was like 6 or 7 discs long, so I had a 5-disc changer, loaded it up, ran through the first 5, and then played the last 2. Sound cards like that help you to be able to do this in a very crisp format. Makes everything sound really nice, especially if you use, if you look at the right-hand side of the card, it's kind of hard to focus, those little gray and black squares. Those are SPDIF interfaces, Sony Philips digital interface for sound. They use either high-speed copper or fiber optic cable in order to transmit sound at a very high quality very, very quickly. So I like these types of sound cards very much. Just bear in mind that your onboard audio at this point probably is just as good. Audio has gotten to a point now where the onboard stuff is usually pretty solid. It only depends if you're trying to record stuff like actual musical instruments or more than one input track. If you're trying to do multi-track recording, that's a little different. So after that long spiel, let's get into adapter cards and laptops. Newer laptops are most likely going to use the mini PCI Express slots. Some of them will use full height, some of them will use half height. So if we look in the bottom left, the arrow is pointing to a mini PCI Express wireless card. It's about the size of a large postage stamp. They're really sensitive, and those 2 little wires you see coming out of the top that's under that piece of tape are antennas. So those wrap around the body of your laptop to try and improve the receptivity of your Wi-Fi range. Now, once we've swapped things out, usually this mini PCI is the only slot you're going to have. You're going to want to make sure that you've got everything securely connected. Follow the documentation, read the documentation, read the documentation. I will repeat it every time I have to say it, simply because it's going to save you so much headache, I promise. Once that's done, boot up and make sure the device is working correctly after the install. You know, you want to go ahead and test it so that way if you need to fix anything, it's already fresh in your mind what you just did. You don't have to, you know, disrupt anything else. So here we can see how to remove the PCI Express card. You're going to take out the retention screw, and then you're going to take off the antennas. I have actually taken off the antennas first simply because they're a little bit stiff. They're very small connectors. I want to make sure I get them off correctly, so I use a pair of tweezers, pop them up, and make sure that I've got those out of the way before I take the screw out. Again, read your documentation, follow what works best there. You know, always follow the directions, because the manufacturer has no interest in you destroying what you've just purchased, because then you're going to go to them for warranty information, and they don't want that. Now let's look at the video subsystem. As a cinephile, you know, somebody who loves movies and TV. You know, I was raised by television. I mean, I had wonderful parents, but I love watching TV and movies. I always have. This is one of my favorite things to talk about. So computer video displays are a combination of two items, a monitor and a graphics card, or a motherboard graphics unit. So that's your primary output device. That's what shows you what you're seeing right now. There's a couple of different technologies that we deal with in order to produce the image that you're currently witnessing. One of the easier ones to talk about is LCD, liquid crystal display. It's also called a flat panel monitor. This was first used in laptops, and we have several layers of glass, plastic, and other substrates in order to sandwich this liquid crystal material. And this liquid crystal material refracts light at different indices based on electrical intervention as well as physical positioning of the treated glass plates. So each intersection of a column and row based on these little electrodes forms a pixel. Pixel is a contraction for the words picture and element. There are two different classes of LCD monitors, twisted pneumatic and in-plane switching. What we see on the right here is a twisted pneumatic application. So the plane of the molecules that is at the rear, where the molecules are anchored on the vertical filter, are twisted at a 90-degree angle to the horizontal filter. And then the color filters are on the front. It's precisely controlled realignment of crystal molecules under an applied electric field. Sounds very sci-fi, but it's actually a fairly simple process. In-plane switching tries to do the same thing, but does chemical treatment of the glass plates to replicate this twist without requiring the same twisted pneumatic style. So it's more expensive, it has more power consumption, it has a longer response time, but it's able to produce a much clearer as well as a much more robust power to weight ratio, if you will. The colors are brighter, they're more vibrant, they are much more true to life, so you get what you pay for. It's kind of like having a V8 versus a V12. You know, the V8's big and sounds loud and nasty, but a V12 will absolutely destroy it, you know, like an Aston Martin Vanquish or something like that. The OLED technology is very similar to the standard LED, but instead of a standard LED, it uses an organic material. It's a layer of film between the two electrodes the same way, but because it is organic, it is going to basically be a bit more susceptible to the electrical fields. It can produce much deeper blacks, much brighter whites, just by separation of what's called intensive contrast and dynamic contrast. It uses less power overall, but because it's organic, it will degrade over time. So we want to be careful with OLEDs. The projector, these are specific types of transparent projection images. Usually it's going to use a series of lenses to flip and reflect the image. So when we look at an LCD panel, this is actually what we're looking at. On the far left, we see a light bulb to represent backlighting. That's what's behind the LCD itself. Now in certain LCD panels, these are actually called LED panels, they'll have a different form of backlighting built in. We have first what's called a polarizer. It filters certain wavelengths of light. We have a glass sheet. We have column electrodes in order to instantiate the column controls. We have a color layer, a liquid crystal layer. Liquid crystal at this point just deals with opacity, meaning that the darker or lighter it is, the more or less light it allows to pass through. On the other side of that, we have our row electrodes. So now we have our column and row intersection, creating our pixels. We have a second layer of protective glass. Then we have another polarizer. You could call it a depolarizer because it kind of reverses what's going on at the beginning of the polarization process. So the image that we see on screen is a series of very carefully constructed filters. It's almost like somebody took little bitty pieces of construction paper and put them in a grid and added or removed them as needed to change an image. So kind of like old school hand-drawn animation where you're looking at 24 frames per second. Every 2, maybe 3 frames, somebody's changing over. Sometimes they'll film it on ones where you'll actually have a different image for every frame. Hand-drawn animation like that was literally taking a drawn image, and then they would take the next piece of paper, trace it, change it a little bit, and flip it. And when the frame moved, you would see a little bit of change. And it moves so quickly, again, 24 frames per second, your eye would register it as being continuous. And the human eye registers somewhere between 22 and 30 frames per second. So the higher frequency ratings of what we see in modern televisions and displays is just to make motion seem more smooth. So it's easier for us to synchronize our eye's own personal refresh rate with that of the display. Here we can see a standard XGA projector by Panasonic. You can see that there's several lenses stacked together in order to change the focus, and then there's a big lamp back behind that that projects the image. So you have an LCD system inside of the lens assembly that is being illuminated from behind. So instead of having a polarization system that keeps the image on a flat panel that we're looking at, we're instead projecting it outwards onto a wall or a screen. Now here are some different technologies and features that you will hear about a number of times if you get working in the video display industry. If you work in selling TVs or Blu-rays or anything like that. Screen size, that's the diagonal length of the screen surface in inches traditionally. Even internationally you'll see them listed in inches, strangely enough. The refresh rate, this is the number of times a screen is built or refreshed in 1 second. That's measured in hertz. So the refresh rate of 60 hertz means that 60 times every second this screen is being completely rebuilt. Related to that is what's called response time. Response time helps to measure the duration it takes to build one frame. So not only do we need to know how long the frame is on screen, but how long does it take to build that frame. If you get a chance, look online. There's some super slow motion video recordings of early televisions and video games, and you can actually watch the electron gun that is creating the image on screen passing back and forth in order to create that image. Pixel pitch, this is a reference to the distance between two adjacent pixels on screen. Now, no matter how small a pixel is, it still has to be addressed individually by software. And to be an individual is to have exclusion. To say that something is one thing is to say that it is not something else. Without getting into a philosophical treatise, 2 pixels are not the same thing. There's A and B, 1 and 2, yes or no, whatever you want to say. So in order to change one, we don't want a change to occur to the other unless it is also being changed by the software. So we have to have a distance between the two of them so that they can be resolved individually. But the smaller that number is, the better, the smoother that transition appears. Resolution is the number of pixels on screen that can be addressed by software. So if we're talking about like an old school display, 620 by 480, or 640 by 480, excuse me, 320 by 480 was even older. Native resolution is the number of pixels that are constructed into a monitor. So if we use this resolution, there's no transformations necessary to make the image fit, so it tends to give us the highest quality image. Contrast ratio is the difference between true black and true white on screen. So, the absolute brightest white and like the deepest, velvetiest black, that is the difference between those two. That is contrast. So if we consider that one is very bright, one is very dark, that is considered to be a good thing. But we have to be careful because there is something called dynamic contrast, where we have backlighting that is dynamically adjusted based on whether or not something's supposed to be bright or dark in order to enhance that. Dynamic contrast is not what you want to shop based on. You want to shop on true contrast ratio. Dynamic contrast makes it look better, but over time will become less precise. You can have some really low quality monitors that can seemingly improve their ratios of display by using dynamic contrast. Viewing angle, this is the angle at which a monitor becomes difficult to see from the side. The higher the better, coming up to a maximum of 180 degrees. 0 degree viewing angle would mean that you couldn't see it looking at it straight on, which would be completely non-useful. 90 degrees is where you're actually facing it dead on. So your face is at a 90 degree angle to the plane of the monitor. And then if you move to the left or right, it's plus or minus. 180 would be if you're staring at it from the side, which I would assume would be terribly difficult to try and view. But there are some flat panel monitors you could probably get close, 175, 177 degrees. Brightness is traditionally measured in candelas per meter squared, which is the same as lumens per meter squared, also known as lux. So there are a ton of different units for brightness, but they're fairly equivalent. Of course, the connectors on your monitor are going to matter. What type of port does it connect to? Does that match up with your graphics input? And then there's all types of other features as well, but they're usually just fluff. So here we can see the rear of this LCD monitor showing analog VGA and digital DVI. It does not have the analog pins on the DVI in order to assist with what's called a DVI-I transmission. We also see that it's got audio ports included, so that may be useful depending on what your particular configuration is. Video cards, also called graphics cards, graphic adapters, display adapters, or onboard video. They can use all kinds of different slots. The new RTX 3090s, 3080s, those are pretty massive. They're triple slot cards, so they are 3 cards high in terms of their space consumption. Integrated cooler requires a lot of extra power. Actually, they need 2 specialized power connectors instead of the 8 pins. We're down to 6 again. So, you know, graphics cards have come a long way from just being built into the motherboard. The different ports provided by video cards, of course, will change based on what your needs are. VGA is pretty much considered to be a legacy support standard. DVI is fairly common. HDMI is more so for TVs. And then DisplayPort is on a lot of portable devices. And then we also have some of the older ones for televisions called component and composite. Composite is where we mix the red, green, and blue signal of the video transmission into one line. It doesn't produce quite as sharp of an image as component, nor does it create quite as sharp of an image as S-video, which also has the separation. S-video was kind of the first way to hook up computers to a video input. I know that was what was going on when I was in elementary school. It's the first time I ever got to play with it, because it looks a lot like the PS2 plug you use for old school keyboards and mice. But as you can see, there's 5 different versions of DVI. So it's always important to understand which one you're trying to use for your particular connector. Make sure you don't accidentally bend up the pins or try and connect a cable to something that doesn't belong to. Now, once the monitor is connected, there's a ton of customization we can do. We can adjust horizontal and vertical position, change brightness, we can change contrast. On a laptop, you'll traditionally use what are called function keys. You'll hold down the little button that says FN, and then F1 through F12 will become a second set of options to adjust brightness and what have you. Whenever we're trying to troubleshoot a peripheral device, we need to start with the least invasive and least expensive solution first. Resetting things to defaults tends to help. So let's take a look at some of these possible errors or problems. Let's say a user comes to us and says they can't even sign into Windows when they're following the password 1 key at a time. Well, do they have caps lock turned on? Do they have numlock turned on? On a laptop specifically, numlock will actually change. It's usually, I want to say it's like UIOJKL M less than greater than on that kind of diagonal slant there into your 1 through 9, and then your 0 will usually be the right hand alt. Sometimes it'll be like P or whatever else, but the numlock will change that 9 key pad. It won't be implanted as part of the keyboard because it would take up too much space. So they have that little toggle there. If that numlock is turned on, obviously if their password was Juniper, then J, U, and I are all involved in that password and would be set to numbers instead. So if they're doing it by themselves, you can always tell them to click on the little I icon to see that they are entering their password correctly, and that can sometimes give them some insight as to why they might be having problems. Device Manager is usually a good place to start troubleshooting peripherals. As we said, that manages all of the drivers and interface connectivity settings, so that's a good place to start. Update your drivers if you can. If there's a problem with driver update, you can roll back that driver. If you uninstall a device and then reinstall it, that can sometimes correct issues. You want to be careful for devices that are currently active. So you want to be like, okay, if I'm using my optical drive, I want to let it finish whatever it's doing and then reset it. Updating ports or slot drivers on a laptop traditionally is going to require using either some external media or something that you downloaded from a website. Just make sure that you have the original drivers as a backup just in case. If you're having issues with your video subsystem, make sure that you check your monitor's brightness and contrast first. Sometimes those can get wound way down, and all of a sudden it causes a lot of display issues. Like with most things with your power supply, if you hear a whining sound, it may be that you have a card that's not getting enough power. Let's say you just upgraded and you didn't upgrade your power supply. You may be running into that issue. If you get a black screen, no display, it could be that the card is in a slot that can't support it. There's not a power connection where there should be, or the onboard video is still giving you issues. If we hear a series of beeps, maybe we should check the post, make sure that there's not a problem. The beeps will usually give you an idea of what the problem may be. Error messages can be problematic, again, conflicts with the onboard video. If the games crash or lock up, if you're trying to play games, check your drivers, check updates for your game, check updates for your sound card. There can be various factors there. Again, updates usually are helpful. If we have no screen image and no monitor light, check the most obvious thing. Is it turned on? Is it plugged in? Easily enough. Always check your cables, always make sure everything's turned on. If the light's on but we have no image, then we want to make sure the video cable is connected. Let's make sure the monitor is set to the correct voltage. That's not really something that happens in more modern systems, but if you have an older monitor, especially one of the big ones, that is something to check. If the monitor displays the post but goes blank when Windows starts to load, then the problem is with Windows, and I would usually recommend using the Safe Mode Boot low resolution video option. There could be a problem with the video card. If there's a cable connection inside the case for a secondary power connector or something similar, check that. Again, check your contrast, check your brightness, check your backlight. Switch out your cables if you can. If you have enough confidence with it, make sure you're grounded. Check to see if any of your chips feel loose. Reseat the video card. Make sure that there's, all the dust and stuff is blown out of your case. If you have more than one video slot, try the other one. If you have a backup video card, try that. Maybe something that's a little bit less powerful. I actually have an old 64 megabyte video card that I keep in a box. It's PCI Express version, I think it's version 2, just for that purpose. So that way if I install a new video card, it seems not to work, let me check the slot first. And then last but not least, of course, we're getting more invasive here. Check your RAM, swap out your motherboard, could be a motherboard problem. Check your power connectors, make sure those are supplying the correct voltage. If you do the power supply lab with me, we always run into at least one power supply that's got a bad connector somewhere, so we always want to test that. If the screen goes blank 30 seconds or 1 minute after the keyboard is left untouched, it's probably in energy saver mode, so just wiggle the mouse. Then you can go into power options and change things, change your sleep settings. If you've got a bad display, you can go ahead and do some calibration stuff. You can go into Windows display settings and adjust your font, resolution, brightness, color depth. Always make sure your video drivers are up to date. I'm not a big fan of these normally, but I have NVIDIA's the GeForce Experience installed on my main machine, and it lets me know when there's a new studio or game driver update automatically. Some updates may actually come through when you do Windows Update. Be aware of that. If you're using a laptop, you may actually have the screen being dimmed by the battery mode. So again, this is when you'd want to check your power settings. Artifacting, this is where we have horizontally torn images on screen. Generally, this is from either overclocking or a graphically intensive codec that cannot be processed correctly. So your video drivers may be out of date. You may have an issue with not having enough video RAM. You may have an issue with an insufficiently powerful display. So that's going to be a couple of things you want to play test. Here we see some calibration screens. We can adjust our gamma, which is a brightness value. That's a mathematical relationship between red, green, and blue. So it changes the amount of light separation. And then here we can see color balance on our grays. So you can adjust based on that. Let's say we have an external monitor that's not working with a laptop. Well, make sure that the monitor is getting power. Make sure that the video cable is snug, the video cable is good. Check to see if there's a toggle switch on your laptop to move between an external projector and the laptop display. In certain cases, there'll be 3 modes, which is just primary display, duplicate, and what's called extend. Extend is where you have the laptop essentially become the width of the monitor plus itself, and it'll allow you to slide one to the other. It'll allow you to keep things like if you have a presentation, you can have a presenter view on your laptop and then everything comes out to the display screen. Again, read your documentation first, be aware of what the limitations are, what your shortcut keys are. If your LCD panel shows a black screen but the power light's on, try and see if there's actually a cutoff screen or a button on the laptop for the LCD. If you're using an external monitor, if that works, but your main display does not, again, try and set things back to defaults, adjust your brightness, but probably your inverter has gone. An inverter is going to take the AC and DC voltage that is coming in, so AC from the wall, DC being brought in, and then passing back into the device itself. If we're having flickering video, that's probably a driver issue, or you may have the wrong refresh rate set. So go in and make sure that all of your display defaults are adjusted. If your cursor drifts on screen when the mouse or touchpad isn't being used, I sincerely doubt that it's anything to do with the video. I don't know why they included it here, but they recommend that you try using a different port or replacing the batteries in your mouse if it's wireless. If you need to replace the LCD panel, number one, we need to test to see whether or not it's the assembly or if it's the panel itself, if it's the video inverter or the actual display. Whatever it is, you're going to follow the same disassembly instructions. Take out your power source, disassemble as need be, again reading the manual, remove your cover screws for your hinge, go ahead and take out the LCD panel attachment screws, remove the top cover of the panel, disconnect the old inverter, and install the new one. Once we've reattached the assembly to the laptop, we should be able to power it up and see if it's all working. So here we can see the exposed inverter. It's difficult to kind of see the bottom one, but the one at the top, you can see there's a little bit of burnout on one of those component chips. Here we can see the ribbon cable that's supposed to be holding that connector in place. So you would use the end of a flat screwdriver to just kind of push it up, and that little wedge is going to release the pressure on that ribbon contact so that it can slide out smoothly. Again, zero insertion force. So once the ribbon is in place, you lock that little tab. It's just going to press firmly but gently across the top. Now let's look at a little bit of customization. This is again going to be helpful for your term project kind of getting started. There are some important principles to keep in mind when we're customizing a system for a customer. We want to meet requirements, any special hardware or applications they may need. We want to balance functionality and budget, and we want to make sure that we ensure compatibility with the hardware. Functionality and budget is important because if it's a purpose-driven build, there's a specific set of components that are really going to support, those are going to feed that build. So let's say, for example, we're building a graphics workstation or a computer-aided design or machining workstation. These are graphics intensive, they need to perform complex calculations, they'll use large files. We need to make sure that we have a powerful video card, lots of fast hard drives, a powerful processor, lots of RAM, and specifically high-speed dual-channel or quad-channel RAM. So this is probably going to be one of the more expensive designs that you'll run into. Audio and video editing, not quite as bad as a CAD/CAM system. You can usually use a slightly less expensive video card, but you will want to make sure that your display is much better. You'll probably want to make sure there's plenty of RAM as well, and then maximum amounts of storage space. If you're outputting to a disk, then you'll want to use a high quality burner. If not, you'll want to make sure that you have high capacity storage to be able to store all of these information pieces. I do recommend getting either a high 1000 or a mid-range 2000 series graphic card at minimum, simply because a lot of video editing suites these days do use hardware acceleration, and you really won't be able to get anything done, especially if you're using non-linear editing, with anything below that. If you're trying to do CPU-based editing, it's going to take you at least 10 times as long. I have definitely run compilations before where it took me 10 to 12 hours to output an hour of video, whereas using graphics acceleration it took about 40 minutes. Here we have some gaming PC examples. This is from iBuyPower.com. I don't tend to recommend buying from sites like this. If you're going to buy a game machine, I would say go through and use that as some inspiration. It's easier to go in and customize and be like, okay, this is really what I want to focus on. So bear in mind, don't do a gaming PC build for your paper based on something from this, unless you're specifically saying, like, I looked at the iBuyPower Snowblind and I went in and verified that this would work, and I used a PC part picker to modify these. I changed out the hard drive, I changed out the processor, blah, 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 blah. Now, gaming PCs focus on having a high-end video card, a multi-core processor, lots of RAM, probably going to be dual displays, and depending, they may either use a high-end headset, like an audio headset, or they may have a high definition sound card. I know a lot of gamers like to have directional sound, so they'll use high-end 5.1 or better headsets. Virtualization Workstation. This is where one machine physically will host the logical activities of multiple machines. Multi-core processor is an absolute necessity, because when you divide up the activities of these machines, it's nice to be able to say, okay, one CPU core for you, one for you, one for you. If you're using an octa-core system, it's really nice if you can do dual-core processing and be able to divvy that up. Extra amounts of RAM when the computer is running several VMs. Remember that each VM has to run its own OS, so the operating system minimum requirements are going to be coming into play for each one. So if you're running Windows 10 64-bit edition, you need at least 20 gigs of RAM, or 20 gigs of hard drive space. 20 gigs of RAM would be kind of a weird number. And then I'd say at least 2 gigs of RAM. I say when I run VMs, I tend to have 8 to 16 if I possibly can. Custom-built home theater PCs, these need to include application software. So I've seen Plex, Ombi, Jellyfin, Kodi, a couple of those. HDMI ports for a PC like this. DVI may also be acceptable. Remember, there are also converters. I've also seen people use things like the NVIDIA Shield in order to connect their home PC and act as a go-between. I feel like that's a little bit of an overt expense, though. Connection to your cable or satellite TV input for web-based accessibility for live TV. Home Run HD is probably a tuner I like for that. Internet access, of course. Remote controls. I have actually used old game controllers with Wi-Fi connectivity. Xbox 360 has an old a wireless controller connectivity you can use, or you can use, if you have the Xbox Elite controller, they actually connect via Bluetooth. Those will work. They do require a little bit of customization on the programming in order to make sure that they'll work as a substitute mouse. I've also used some smartphone apps that have some basic what's called a DLNA based remote control. The Logitech Harmony series is pretty handy. Low background noise, surround sound. If you want to have a 7.1 sound, you got to make sure you have a 7.1 card, and you have to make sure the software supports that channel separation. And then your form factor, of course. Make sure it's small enough to fit on the shelf of an entertainment center. A lot of home theaters these days, though, tend to draw from a file server, like mine does. I have all my stuff set up on a file server that is in my office, so it doesn't matter how loud the fan is, unless it's causing the walls to shake, I'll never hear it in my living room. Home servers are useful to share files among several computers in a small home network or office. At this point, you need to maximize storage speed and capacity, and then network transfers. So, most of your onboard stuff is fine. Windows 8.1 is even an acceptable option. Just make sure that you're keeping it secured. I would start migrating to Windows 10, though, because that's going to hit end of life pretty soon. Virtualization server, we talked about virtualization a little bit ago. The server is going to provide all of the grunt. That's going to give you the hardware you need to run things. The clients are going to be what logs in. A thick client will be a standard desktop computer that could run the virtualization server itself as well as the client. And then a thin client has very little power on its own, and then will communicate via usually like a web browser or something similar. In order to reduce costs, they recommend that you configure it only to meet the minimum requirements for Windows. I would say, again, use that 30% rule, because if there is an update, you don't want it to become non-functional overnight, especially if you're right on that borderline. A NAS, network attached storage. These are standalone devices that can serve up and stream media files to your clients without having to have a PC that backgrounds it, but there are some that are basically taking old PCs and converting them into a NAS. Moderate power processors, RAID-array capabilities, moderate chassis, gigabit NIC, because you want to be able to transmit at very fast speeds, and then media streaming capability, free BSD. There's a couple of different operating systems that will run that. CentOS. And here we can see an 8-bay NAS, so you've got 8 3.5-inch bays. Even if you were to just pull like a standard 1 terabyte, that's still a massive amount of storage. If you were to do a 2 or a 4, then obviously you'd be able to store a significant amount. It would depend on your resilience for the individual drives, whether or not you'd want to set up a RAID cluster as, RAID 0, RAID 1, or 1.0 in order to improve fault tolerance. So that is it for this chapter. If you have any questions or concerns, as always, I am more than happy to take your emails at jearmke063@cfcc.edu. Or, of course, you can text me on my Google Voice number 239-7814. Or you can always just come by the office. I'm always glad to have people come and visit, come and have a chat. Socially distance, of course, with your mask. Can't be spreading those germs. Other than that, I hope you guys had a fun time watching this video. I know it's a little dry, especially when we get past the 1 hour mark, but thank you for sticking with me. Hopefully I can alleviate any of your concerns about building your own custom system in future. I'm sure you guys will do awesome on your term project. As always, it's been a pleasure having you, and I'll catch you next class.